All right, let's take a look at number 3 here. In the figure above, it shows an above ground swimming pool in the shape of a cylinder with a radius of 12 feet and a height of 4 feet. The pool contains 1,000 cubic feet of water at time t equals 0. During the time interval from 0 to 12 hours, the water is pumped into the pool at the rate P of t cubic feet per hour. The table above gives values of P of t for selected values of t. During the same interval, water is leaking from the pool at a rate of R of t cubic feet per hour, where R of t is 25 e to the negative 0.05 t. Note volume of cylinder with a radius r and height h is given by this formula. Part A. Use a midpoint Riemann sum with 3 subintervals of equal length to approximate the total amount of water that was pumped into the pool from 0 to 12. So we've got this information, and we're using a midpoint Riemann sum. Show the computations that lead you to your answer. So we can do this with a graph, but we can also do it without one. We're going to 3 subintervals. So we're going from 0 to 4, 4 to 8, and then 8 to 12. So on the interval from 0 to 4, what's our midpoint? 2, right? So 2 is where we're going to get the height of our rectangle for this Riemann sum. Well, the height of the rectangle is going to be 46. What's the base of the rectangle going to be? If we're going from 0 to 4, the base of the rectangle is 4. All right, so we get 4 times 46 for our first rectangle. Second rectangle is going from 4 to 8, so that has a base of 4 also. Height is going to happen at the midpoint. The midpoint is 6, so our height is 57. Last interval, also a base of 4. Height is going to be 10. Sorry, height occurs at 10, that's going to be 62. So if we go ahead and multiply these and add them up, that gives us our approximation for part A. That comes out to 660. And that would be in cubic feet.
Oh my God. Why?